Okay, so parallelograms means that we have two parallel lines. So there's one set, and there's the other set. Let's do some labeling. Inside, we want to draw the right angle for the top to the bottom, and that's, once again, that's called the altitude or the height. Altitude. Another name is height, which we'll use H for height again, just like with the triangle. And the bottom is the base. And we will use B for base again. Okay? So what we're going to do is we're going to prove the area of a parallelogram. So here I got my parallelogram. I labeled my height already. So what I want to do is I want to say, well, first of all, let's label our H. And we'll label our B. I'll label it up here. Let's relate it to something that the students already know. The students know the area of a rectangle, correct? So if the area of a rectangle is base times height, we could just cut off the corner of this parallelogram and we can make a rectangle out of it. So since a rectangle is a parallelogram, then the area is going to be the same. So we're just going to simply is equal to the area of a rectangle. So therefore it's equal to base times height. And that's what we want to show. That's it for a parallelogram. So that's pretty easy. Now we're going to show the proof for a trapezoid. So once again, let's do some terminology. Alright, I'm going to draw my altitude or height. Forms a right angle here, and it forms a right angle here. So altitude. Another word is height. And we're going to use H again. Now, the bases for the right angles. So we have two bases. So we're going to call this base 1. And we're going to call this base 2. Alright, so here we go. Here's the proof of a trapezoid. So I got my picture of my trapezoid. I'm going to actually fill in some stuff. I drew in both altitudes. I drew in this one and this one. Okay? So what we can do is we can tear stuff apart and rearrange it. So what would happen if I would take my triangle and I just move it down? Actually, I'll do it this way. I'll take my rectangle out. And I'm going to shift. So now what happens is I have a triangle formed. And a rectangle. My total is base 2. And this distance was base 1. Okay? And so now what we need to look for quick is, well, what's this distance right here? Well, that distance is equal to base 2 minus base 1. So I'm going to put that in there. There we go. So now the area of my trapezoid is just going to be the area of my rectangle plus my area of my triangle. So the area of my trapezoid, I'll just draw the figure like this, is equal to the area of the triangle plus the area of the rectangle. So the area of my triangle is 1/2 base times height, so it's 1/2 times B2 minus B1 times my height. Area of my rectangle is base times height, which is B1 times H. Alright? So now we're going to do some algebra. I'm going to do the distributive property here, and I have 1/2 B2. Well, actually what I'm going to do first is I'm going to put this H out front. I'm going to reorder my numbers. So I'm going to have 1/2 H times B2 minus B1. And I will rearrange these letters to H times B1. You could do that. It's just going to make it look prettier. Now let's do the distributive property. So we have 1/2 H B2 minus 1/2 H B1 plus H B1. Now if you look, we got some like terms here. I have negative 1/2 plus 1, because that's a 1 in front. So this is equal to 1/2 H B2, and 1 minus 1/2 is equal to 1/2, so plus 1/2 H B1. Hey, I can factor out a 1/2 H. So I'm left with B2 plus B1. And that is the area of a trapezoid. Alright, so you technically don't have to memorize it. You could just simply say that's the area of the triangle and the rectangle put together. Alright, thank you.